Alright, so this video is going to cover vertex form graphing. Welcome back, by the way. I just uploaded a video a second ago. The other one's on vertex form and its various dilations. So this one's going to be specifically on its graphing. Alright, and we'll just start with a graph that we're used to. Something like f of x is equal to x squared plus 6x, I don't know, plus 2. Something like that. Now you could easily do this with your vertex formula, negative b over 2a, all that jazz, but this, on your test, we're going to also have it where you have to like change things into vertex form and graph things from vertex form. It really doesn't matter which version you use to graph your vertex form. That's actually not relevant at all, but every once in a while it'll be easier than the other, and plus I'm going to give it to you in both ways, so I would kind of recommend that you're comfortable with both just so that you don't have to waste your time converting from one to the other. But there is this conversion for those of you that feel really good about vertex form, or you can always convert back by just distributing. We'll actually do both in just a second. So first, in orange, I'm going to go ahead and show you how to change it into vertex form. Alright, so this is standard form. Right now it's standard. You guys are used to that. And we're going to change it into vertex form. Okay, so in orange I'm going to change it into vertex form, then I'm going to change it back. Alright, so let's go ahead and change it into vertex form. What you need to do is you need to perfect the square, or complete the square. So you'll notice that these two parts, they work for a perfect square, but this c is wrong. Like if you take the square root of this c, you'll get, I don't know, 1.3, some kind of weird decimal that definitely does not multiply into 6. Alright, so the square root of this times 2 does not equal 6. So we're going to go ahead and just complete our square. Remember, to complete our square, you have to use this formula, b over 2 squared. Our b in this case is at 6. Remember, b is always attached to just that x. So it's 6 over 2 squared, which will give you that 6 divided by 2 is 3, squared is 9. Okay? So you're just calculating b over 2 squared. So I know I need to add 9 to both sides of this equation. So I'm going to go ahead and add 9. I'm also going to rewrite this as y, just so I don't have to keep writing f of x. Alright? So y plus 9 is equal to x squared plus 6x. One thing to know, like a little thing to highlight here, is that when you add that 9 to this side of the equation, go ahead and put it right next to the rest of your trinomial perfect square, just so that you get the whole perfect square all together. And then this 2, don't forget about it, it just sits at the end of your equation. Okay? Now we're just going to factor. That's all it is. So now we factor. Remember this, completing the square, b over 2 squared, factor. Okay? So let's go ahead and factor this. And you'll get x. Remember, to factor this, you just take the square root of this final term. Square root of 9 is 3, so we know it's going to be x3 squared. And to figure out the sign in the middle here, you just look at the sign of your b. There's a plus sign. Okay? Rewrite the rest of the equation. You can condense a lot of these steps together. Alright. The last thing we have to do to get it into x minus h form is that we need that k to be fixed. So we have to have it as y equals. It can't be y plus or minus some stuff equals. It has to be y equals. So we got to get rid of this plus 9. To get rid of that plus 9, all you're going to do is subtract it. Basic equations, things you guys did back in like 3rd grade, you're getting to do them now. Okay? Y is equal to x plus 3 squared. And then 2 plus negative 9 is that negative 7. And congrats. You now have your A. Oh, let's go ahead and label some points, by the way. Your A is this 1. So there's like an invisible 1 here. Remember, in front of any variable, in front of any parentheses, you can multiply it by 1. So your A would be 1. Your H would be 3. Well, your h would be the opposite of this, so it would be negative 3, okay? So h would be negative 3 in this case. And then your k would be whatever it is. And this one's a negative 7, so your k is negative 7. Alright, so just remember your a and your k, take whatever signs you see them in, but your h, you have to flip it. Your h is going to be negative 3 in this particular equation. Alright, that's it. That's how to change vertex form into standard form into vertex form. And then let's go ahead and go backwards. I'll go ahead and do this in blue and on the same page. It won't take long. So this is for the people that really, really like standard form and negative b over 2a and all that jazz. All you're going to do is you're going to distribute. Okay? So 1, we're not even going to bother distributing. The first thing we want to do is go ahead and do our exponent here. So you're going to change this back. I'll actually do this on a different page. For those of you that aren't interested in, sorry. For those of you that have no interest in changing it back into standard form, go ahead and skip the next like 2 or 3 minutes of this video, because it's not like I'm here to confuse you. This is just for the people that happen to like what we learned a couple weeks back. So for the like 3 or 4 people that really like standard form, this is for you. Y equals x plus 3 squared. What was the last value? It was minus 7. Okay. And all I did was I rewrote the equation from back here that you guys just solved. All right, so our goal is going to be to get from back here back up to this. And all you're going to do here is you're going to FOIL this out. So y is equal to x plus 3 times x plus 3. And again, you can combine steps. There's no reason to really write this out, but I'm going to go ahead and write it out just so that you guys see every single thing that I'm doing. First times first is x squared. Outer times outer is 3x. Inner times inner is 3x. Last times last is 9. Don't forget you have that minus 7 at the end. Let's go ahead and combine like terms. X squared, 3x plus 3x is 6x. And then 9 minus 7 is 2. And you'll notice that we got back to x squared plus 6x plus 2 from here. And it's the same exact one we started with. X squared plus 6x plus 2, x squared plus 6x plus 2. That's all you have to do to change vertex form into standard form. It's a much easier process. Okay? So I think that covered about 2 or 3 minutes of the video. So by about here is where we should be back. Everyone should be coming back to graph this. So I'm going to graph it from vertex form. I already taught you guys how to graph it from standard form. That said, there's really no difference between the two. All right? So let's take our vertex form, which was y is equal to, and I'm going to go ahead and write the 1 here. So that's your a, just so you guys get used to it. I wouldn't really recommend writing it for the most part when you're actually doing these problems, but I'm going to do it just so that you guys can see it. This is a good way to start. Go ahead and write your 1 if it makes you happy so that you never forget. So let's go ahead and name our spots. So this is our a, is just positive 1. Our h is negative 3, and our k is a negative 7. It's kind of a bad example because I've got a graph that's like largely on the bottom half of the graph, but that's okay. So I'm just going to draw like that. There we go. And again, you have 1, 2, 3, 4, 5, something like that. 1, 2, 3, 4, 1, 2, 3, 4, 5. And this one's going to have to go down quite a bit. So I'm going to go down 7 spots. 2, 3, 4, 5, 6, and 7. All right. So the first thing you're going to do every single time is you're just going to graph your vertex. Remember, your vertex was hk, and your h is going to have the opposite sign of what it has in your equation. So it was a positive 3, so your h is actually a negative 3. 1, 2, 3. And your k is a negative 7. So we're going to go over 3, 1, 2, 3, down 7 spots, and I only made 7 hashes, so I already know how far down that is. Okay, so this is negative 3, negative 7, and that is your vertex. All right, from here on, we could just find some points. You can just test some random numbers, and you may get some decimals. This one actually works out really pretty to where no matter what, you won't get decimals, so you could just test like 0. In fact, I would highly recommend 0 in most cases, but you never know. You could end up with a really bad value. The other option is to go ahead and find your x-intercepts, which we talked about in class. I'm going to go ahead and do x-intercepts just so that you guys see what you're doing, but for the most part, you could just make an xy table. Okay, xy table. And just start plugging in some numbers. For example, let's go ahead and plug in 0 because it won't take very long. I'm actually going to graph like 3 or 4 points on here just so that I can show all the different ways you can get points for this. But let's talk about our 0. So 1 doesn't really matter. What's 0 plus 3? Hopefully you notice that that's 3. 3 squared is 9. 9 minus 7 is 2. So our first point here would be 0, 2. That's actually our y-intercept. All right, so our y-intercept would be 0 left to right, up 1, up 2. That's our y-intercept. That's 0, 2. So 0 is a really good point to start off with. when graphing parabolas, because you'll get your y-intercept. And then again, remember you do have your axis of symmetry, but we're not doing standard form right now, so okay, that was a really bad line, but that was supposed to be more of a U-ish. But remember that if you have this, if you can imagine your axis of symmetry, or I guess if you really want to add it and whatnot, because it's not really part of vertex form, but it was 1, 2 spots over, 3 spots over. So we would just go 1, 2, 3 spots over as well. So I know my y-intercept, so it gives me the second point as well, and we get this parabola. Looks kind of like that. All right. We could also find our x-intercepts specifically. So let's go ahead and find our x-intercepts. All right. On a different page, I'm going to find our x-intercepts. But this is the simplest way to graph it. You graph your vertex, find your y-intercept by testing 0, and then you just mirror that same thing. Because remember, there is this axis of symmetry, which we do not do in vertex form typically, but you certainly could. It doesn't hurt. It's just not in your textbook. But you absolutely could make your axis of symmetry and then just mirror it. This is the easiest way to do things. Let's talk about x-intercepts, because x-intercepts you need to know how to do in every single graph. Those are your answers, and you guys have already kind of done this. But anyway, for any given graph, so again, our equation was f of x or y is equal to 1x plus 3 squared minus 7. Alright, and there was that invisible 1 here. I guess I'll write it just for consistency's sake. And if you wanted to find your x-intercept, so find x-intercepts. Find your x-ints. All you're going to do is you're going to set y equal to 0, solve for x. And you're going to use square root property here to solve for x, just because it is a quadratic in vertex form. Okay, so let's set y equal to 0. I'm going to go ahead and do this in orange. Y equals 0, but everything else is going to be exactly the same as what you're used to. It's still 1, it's still x plus 3 squared minus 7. From here, let's go ahead and just solve. So you'll want to add 7 to both sides. And you're going to get 7 is equal to, I'm going to get rid of the 1 because 1 times all this is the same thing anyway, so I'm just going to skip writing it. And then 7 and 7 cancel out. That's the purpose of this whole thing. Now we have to get rid of this squared, so we're just going to square root both sides. Square root of 7, remember, is that plus or minus square root of 7. So plus or minus, don't forget your plus or minus sign, equals, and then the square root of anything squared just leaves you with what's underneath that square root. All right. From here on, what you're going to do is you got to solve for x. Well, I mean, that's what we've been doing, but we got to get rid of this plus 3. You're going to do that by subtracting 3. Subtract 3. And all you'll end up with is x is equal to negative 3 plus or minus the square root of 7. And there are your x-intercepts. Technically, your x-intercepts would be at, what is negative 3 plus the square root of 7? Square root of 7 is somewhere around 2 point, it's like 2.5, 2.6, something like that. So you're basically plotting a dot at negative 3 plus 2.5, which will give you like a 0.5. So this is somewhere between 0 and 1. And then negative 3 minus 2.5, which should give you like somewhere around 5.5. All right. So if we look at our graph, if we look at our graph, I definitely didn't put this quite where it was supposed to be. It should be over like a little tiny smidgen as well. And then over here, it was 1, 2, 3, 4, 5. I put this one too far over. It probably should have gone like more through the middle of my 6 and my 5 here, but that's okay. That is how you find your y-intercept, or I'm sorry, your x-intercepts. Okay? So remember, x-intercepts, you set y equal to 0. I guess let's go ahead and make this point for those of you that really haven't gotten used to it. You really need to memorize this. This is something you should have learned back in geometry or algebra 1. But to find y-intercepts, you set x equal to 0. Or I'm sorry, yeah, set x equal to 0, solve for y. They're literally opposite steps. And again, you really should have memorized this at some point. If you haven't memorized it in your other classes, you should memorize it now. Okay? So this is the easiest way to find really valuable points. X-intercepts, y-intercepts, you're capable of all these things by now. So this is how you graph your vertex form. Okay, so you guys should be good. Shouldn't be a problem. We converted, we graphed, we did all this. We found x-intercepts, found y-intercepts. So it's very possible on the test that I will give you an equation like this, and I will ask you which of the following graphs is correct, and I'm going to give each of them different x-intercepts. They might look very similar. They might be all facing down. They might all have the same vertex, but you have to have the right x-intercepts, okay, or the right y-intercepts or something like that. Yeah, hopefully that covers everything. You guys should be good. Let me go ahead and let you guys see every single page in this again so that you can pause. All right. So graphing vertex form, this is how to change from standard form into vertex form. It's not that many steps. You really just do your b over 2 squared. You add that value to both sides. And after you've added that value to both sides, you go ahead and do your regular square root property. So you factor and then solve for y. So you factor that out and then you solve for y. You just have to subtract whatever it is that you added over here. Typically, it's going to be a positive or negative number. You're just going to add or subtract it down to this. And then you'll get your k. Okay? Just a couple of steps. B over 2 squared, factor, square root property, solve. And then on the next page, we practice going backwards. So from your vertex form, this one's even easier. If you like standard form, to switch it back to standard form, all you're going to do is, well, essentially PEMDAS, order of operations. You're going to distribute your exponent, FOIL it out, and then combine like terms. You're done. From here, you've got your graph based on your XY table. So I just found a y-intercept and then I mirrored that y-intercept over here. And this isn't the most accurate graph, but it does give me 3 points, all of which are critical points. So that's all you really need to do. If you can find your y-intercept and mirror it across an axis of symmetry, you are all good. Again, this is not exactly how the textbook does it. They ignore axis of symmetry here, but this is really the easiest way to graph it. Okay? Further, if you are ever asked for x-intercepts or y-intercepts, this is the same as when you guys solved it in a line. When you find the x-intercept of a line of any graph of, parabola, hyperbolas, whatever else, your x-intercept is always going to be when you set y equal to 0, and your y-intercept is when you're going to set x equal to 0. All right? Best of luck, guys. Again, contact me if you have any questions. See you guys later and have a great weekend. Bye.